So we've got some work to do on sequences and functions. And so share my screen, as you can see me here. I'll switch that over. Here we go. Should be set to go. So notice in your diagnostic, go ahead and find this question. So act like you're taking it, and it doesn't matter first time or second time it occurs because you got the same question twice. Piece of information that we need is the following. So key things, if you have a sub 1, the first term, and an explicit, you need n-1 for your variable. And if you have the opposite, well, not the opposite, but if you have a sub 0, 0 term, and explicit, you need n. Okay, so as we take a look at what we've got here, we're told that 45 is the first term in both of them. And it works really well if I just do a table here to see what the first and second differences are if I need to. So we've got our first term is 45, our second is 38, our third is 31, our fourth is 24, our fifth is 17. And for each of those, we're subtracting 7. So our first differences every single time is -7. That's all the same. So that means it's linear or arithmetic. And so we're looking for a -7 in front of the n, and we've got that in 2 places. Okay, so that means the other 2 are thrown out. So that means B and C on number 1 are thrown out, A and D are thrown out on the second one that I've got up here. And then trying to figure out what we need. Well, we need a -7, and then if we notice, our first term is 45. So that means on this one right here, I can't work with it because I don't have an n-1. I have the first term, I need an n-1. So that one gets thrown out, and we would just be this one. The other way to take a look at that is we need the 0 term. To get the 0 term for f of n equals d times n plus a sub 0, we go back. And so instead of subtracting 7, we would add 7, which would get us to 52. I'm going to pause the sharing and get the next one up. So here's our next one. So find that question if you need to, pause the video. And I've got this broken up into kind of 2 places. We've got explicit on the left and recursive on the right. This is select all that applies. So we talk our first term, and I'm just going to go put it in an XY format here. We got 1 is 12, 2 is 24, 3 is 48, 4 is 96, 5 is 192. I look at it and we've got right here, our first term is 12. Well, that doesn't work for B, so I get to throw B out, but that does work for D and E. They both say f of 1 is 12. Now we look at the differences. Am I adding 12 or multiplying by 2 every single time? So let's see, that first difference is plus 12, and then it's plus 24, and it's plus 48, and then it's plus 96. So first differences are different. Second differences are different as well. So it's not adding, so it's not linear. So I can throw that one out. And that means it is this recursive. We are multiplying by 2, and we can check 12 times 2 is 24, 24 times 2 is 48. It works. So then we take a look over on the left, and both of them have the first term. That means I need an n minus 1 in my equation. So that makes it A, and C is thrown out. So only 2 of them work. Going to get the next one, so I'm going to pause this for a moment, get the fourth question up. I actually decided to go with the fourth and fifth because I could fit them in there. So as we take a look at these two, we're told in both that they are geometric sequences, so we're multiplying by something. So for number 4, that's, oops, helps if I write the right thing. 1, 2, 3, 4, 1, 2, 3, 4. We're asking for the 7th term. 7, negative 14, 28, negative 56. That's what we're given. We want to know what the 7th is. Number 5. We're told the first 4 terms. Was it 16.2, 54, 180, 600. Okay. Since we're told that they're geometric, that kind of tells us we're multiplying by something. So 7 times what's negative 14? Well, that would be times by negative 2. Negative 14 times negative 2 does get us negative 28. Times negative 2 does get us negative 56. So if I take that times negative 2, that's going to be a positive, and just double that. Well, 6 doubled is 12, 10 doubled, or 5 doubled is 10 plus an extra 1. It's going to get us 112. The next one's going to be 224, and that's negative 224. The last one, double that. It's going to be a positive 448. Okay. For 5, they want to know what we actually multiplied by. So the quick way to do that is you take the second term and divide it by the first term. So I take this number divided by this number. So we have 180 divided by 600. If you put that in the calculator, you're going to get 0.3. So that means 600 times 0.3 is 180. 180 times 0.3 is 54. 54 times 0.3 is 16.2. So now I just need to take 16.2 times 0.3 to get our 5th term. And that's 4.86. Okay. Remember, if you ever need to pause the video, go ahead and do so and then start it up again. I'm going to stop sharing this and get the next question going on here. Okay, the next one, share my screen here with you. Owen loves reading and started counting the total number of books read this year. He adds up the total at the end of each month, and his list is as follows: 4 at the end of the first month, 7 at the end of the second, 10 at the end of the third, 13 at the end of the fourth. And we want to know how long before he gets his 25th. Well, we take a look at this, what's going on. 4 to 7, we added 3. 7 to 10, added 3. 10 to 13, added 3. So we keep adding 3. So we could keep adding 3 till we get to 25. Which gets us to the 8th month, which is 4 more months. Or we could have also looked at it. We want to get to 25. We've got 13. That's 12. How many times does 4 go into 12? It goes in, I said it backwards. How many times does 3 go into 12? And it goes in 4 times. Because it keeps going up by 3 each time. Okay. So I'm going to stop sharing and get the next question up. Here's our next. Excuse me. Amir has a summer packet of math problems, and he's does so many problems a day. We want to know which equation represents his problem solving. So I got my X and my Y up here. Well, 20 is kind of where it starts. So that kind of sounds like that's the 0 term. And at the end of each day, he's got 4 fewer problems. So it looks like an arithmetic where we just keep subtracting 4 each time. So that right there tells me my common difference is a -4. There's only one of them that's got a -4, and then it's got plus 20 as the 0 term, which makes sense. That's why it would be D. And you can also check if I do -4 times 0 plus 20, I get 20. -4 times 2, well, that's -8 plus 20, which is 12. It works. Okay. Pause this again and get the next one. Okay, our next right here. So Jason studied how quickly ants consume things. He counted the number of ants on a banana peel at the end of each of 5 minutes. And he started counting. So let's see, we've got X and Y. At the end of 1 minute, he had 12. At the end of 2, he had 19. 3, it's 26. 4 is 33. And then at the end of 5 minutes, he had 40. So we look at that, that keeps going up by 7 each time. So I'm looking for a times 7, which would be either of those two. And then we just look with the 0 term. So go back, that would be 5. That's why it would be this one here. I'm going to pause the video and get you going with the next. Okay, we have 2 more problems to do, and they both deal with tables. So our next one, we're given the frequencies, and we want to know if it's a geometric sequence. It tells us that right there. What is the value of the common ratio, not ration? That's me and my typos. Okay, so ratios. So again, all you do is you take the second term and divide by the first term. And our second term is 416. Excuse me, we're going to pause and get back to what we wanted. And so our second term is 466.616, and our first is 440. Now right there, I can kind of look at it. 466 is bigger than 440, so it should be bigger than 1. So that gets A goes out. Then I also kind of look at it. 466 isn't that much more than 440, so it's not going to go in 26 times. It's not going to go in 27 times. I didn't do any math, and I just kind of have it figured out. But pop up your calculator. Take 466.16 and divide it by 440. And you get 1.0594545, and it keeps on going. But this says to the nearest hundredth. That means second decimal place. So I take a look at it, and the third is a 9. What does it tell you to do to the 5 in front? It says to round up. That's why it's 1.06. Okay. One more. So I'm going to stop sharing and pause it and get the last one up. Here we go for the last one. So Regina counted the number of emails she received during the first 5 days. She used her new account. The results are recorded in the table below. Notice all the answer choices down here. They are all arithmetic, so I can look at what I'm adding to get the next. We're adding 4, adding 4, adding 4, adding 4. So I need a 4 in front of the n, which that's only that one. And then we can double check to make sure that that actually works. If I plug in 1, 4 times 1 is 4, plus 3 is 7. That works. Otherwise, I could have just taken like the first one n and 7 plus 2n. I plug in 1, that's going to be 9, which isn't 7. I plug in 2, that's 11. That did work for the second term, but not the first. If I plug in 3, 6 plus 7 is 13, so that definitely is thrown out. If I do, that's for A. I'm just showing why these don't work. If I do C, 1 gets me 7, but 2 gets me 8. Doesn't work. If I do D, which is 3n plus 4, if I plug in 1, I do get 7, but if I plug in 2, I get 10, not 11. And like I showed up here with B, we do n and 4n plus 3. 1, we get 7. 2, that'd be 8 plus 3, which is 11. 3 is 12 plus 3, which is 15. It keeps working for each of them. That's why B works. Okay. So stop share, and then you should have pretty good notes on this, and your diagnostics should be good and be able to take that power focus area.